We are starting Module 9 and getting into more of our geometry unit. And so I need you to do a couple of things. One is get your notes ready. Two, make sure you have a calculator because we're going to use it a ton. And of course, your handy dandy pencil as we work through all of this. All right. So in your notes, let's start here. And I want you to put this as your essential question. How do let me grab my specific stuff here. How do I find and use circumference of a circle? Believe it or not, there are many, many items of a circle. There are many items in life that are circular, and especially when you start to think of how people design product packaging and how many things come in something that's circular in shape. Think of every single solitary cans of soup, cans of tuna, cans of fruit. I'm thinking specifically about something like our wipes that we use so often to clean in school and things. All right. So first things first, what I want you to do is let's get some of this terminology formally written down, because I know that you've talked about circles and things before, but I want to make sure we have the formal, more mathematical definition. So when I say radius and you look at this diagram here, do you remember which part and what the radius is and what it means? This guy right here, I'm going to put an R on there. That is the radius. And what the radius is that it is a part of a line. So we call that a line segment. Now, technically, a line goes on forever and ever in eternity, but a line segment starts and stops with things called endpoints. So when I look at this radius, here's what I'm going to tell you. It's a line segment. One of the endpoints, and I'm going to abbreviate endpoint as ENDPT. One endpoint is at the center of the circle, and the other endpoint, so I'll just say one endpoint again, is on the circle. So that's what the radius is, okay? Bloop, from the center, and it could be drawn anywhere as long as it reaches the circle itself, okay? And that's what a radius is. How about diameter? Do you remember what diameter is? That is, well, all the way down there. That's diameter, the whole stinking thing. In fact, maybe it'd be better if instead of me trying to draw some crazy weird bracket here, how about if I do it this way? Call this D, and it goes from here to here. I'm going to put dot here and here. Okay, so now mathematically, the way I'm going to explain this, line segment, and we can say both endpoints are on the circle. Both endpoints on circle. Now, I've got to be a little careful here, because if I just say it's a line segment and both of the endpoints are on the circle, I could try and draw something like this and say, okay, that's a diameter. And you'd have to say, no, that one doesn't qualify. I guess I need to be a little more specific here. I've got to add one more detail about a diameter. Besides both endpoints being on the circle, it also has to pass through the center. So it has to pass through the center, or in other words, it intersects that center point. Okay, awesome. Now we got to get to some things about pi and circumference and what the formula for circumference looks like. So take a little break here. have your calculator ready, because I want to take a look at this thing, which is my little handy dandy tub of Clorox wipes, okay? And I'm going to give you 2 measurements, and I want you to get your calculator ready, all right? So if I wrap this tape measure all the way around the outside of this tube of Clorox cleanups, okay, right here, I'm going to measure it in centimeters, okay? And I get approximately 34.2 centimeters, okay? This is called the circumference because I went all the way around the outside. It's kind of like measuring the perimeter. And in fact, I lied. Let's go back to this. So circumference, we can grab our pencil again. This is the distance around some circle or circular object. So distance around a circle. In normal polygons and other objects that have edges and sides, we call this the perimeter. But because this is a circle, we use a little different phrase called circumference, okay? It's the perimeter, the distance around the circle. So going like this, all right? So I'm going back to my tub of Clorox wipes here, okay? I measured the circumference at 34.2 centimeters. Then, let's say I wanted to measure the diameter going straight across here. And I measured that in centimeters. And when I did that, I got smack dab exactly 11 centimeters, okay? Here's what I want you to do. Will you grab your calculator and take the circumference value, which was 34.2, and will you divide it by the diameter value, which was 11? And tell me what you got. Well, you can't really tell me, but look at your calculator screen and see what you got. We get something that's about 3, and this ends up being a long repeater, 3.109090909. It keeps on going like that. So it's around 3.1, or if I went to 2 decimal places, it's about 3.11. How about that? That looks awfully close to something that I recognize. Ta-da! Pi. Do you know what pi is? Pi is a number. It's a number that we represent this way, okay, with the Greek symbol, Greek letter pi. And it happens to be the ratio of a circumference to the diameter of a circle. For many, many, many years, people, even before we had calculators and computers and things, they've known that there's something special about this relationship between circumference and diameter of something circular. It's a little bit more than 3. And that's why we've discovered, with all our fancy schmancy technology, that this value for pi is really some sort of weird irrational number. And when I say irrational, I mean that when we try to write it as a decimal, it never ends. They've hooked up computers trying to compute this thing. It doesn't repeat. It doesn't end. It's just this freakishly weird thing that just keeps going, going, going with some sort of weird random pattern, or not a pattern, just a random series of digits, and it just keeps going and going. It hasn't stopped. Because this number is irrational, we often use an approximation. So we cut it off at approximately 3.14. When we use a decimal, we often use 3.14. Sometimes we can also use a fraction approximation of 22/7. In fact, take your calculator right now and put in 22 divided by 7. Get it as a decimal and see what happens there. Kind of freakishly close to 3.14159 if you remember what that looked like. Also, here's something else that's kind of cool. Your scientific calculators happen to have a pi button. So if you take a look at the ones we use, the TI-30 XS multi-views, if you find the pi button, which is kind of kitty corner from the 7 and up a little bit, and if you just hit enter, it just says pi over and over again, the symbol. But if you hit that toggle button above it, then it gives you as many decimals as it can show, 3.14159.265, and just keeps going, okay? To be super exact, we would just leave the symbol pi as pi, but because we usually want to get some sort of idea of what this equals, we are going to use either the 3.14 approximation or the 22/7 approximation. Our formula for circumference looks like this. Capital C equals pi times diameter. That's how you're going to see it on your formula sheet for your Minnesota comprehensive assessments. And sometimes you might see it written this way. 2 times pi times the radius, or just 2 pi r. And the reason we do that is, we didn't even talk about this. The radius is actually half the distance of a diameter. The diameter is 2 times the radius. That's the relationship they have. So that gives us all kinds of information. Let's get to doing some computation. A circle that has a radius of 14 meters. Go ahead and eyeball where the center is and draw any old radius and label it 14 meters. If you know the radius is 14, you know the diameter immediately. You don't even need a stinking calculator. You can just do that in your head because there's another 14, so the diameter is 28. If I ask you to calculate circumference and I say, hey, let's be exact, write the word exact here. Let's be exact and leave pi as the symbol pi, you would say pi times 28. If you do that on your calculator right now and use the pi symbol, it will just spit back to you 28 pi. Usually we put this number in front of the pi symbol, even though they're both numbers. We just typically do it this way. So 28 pi, that's exactly the circumference of that circle. Notice if I say, hey, let's use 22/7, the fraction approximation, then you'd say 22/7 times 28. Notice I'm not using an equal sign now. I'm using this tilde, and I should use 2 of them there to say approximately. So draw a second one under there because frankly, I couldn't figure out how to type that. All right, when you plug that in to your calculator, look how nice this is because 7 fits exactly as a factor there, and you get 88. Label it meters. Oops, I forgot to label that one meters. Do that. So 28 times pi is really, really close to 88. If I said use the decimal approximation, 3.14, add a second tilde there, and you on your calculator say 3.14 times 28. Crank that out and you get 87 92/100 meters. Okay? 3 different ways to calculate it. This one is always exact because we left pi as the pi symbol. We didn't approximate it. With the fraction or the decimal. Okay? So depending on your directions, we'll have you calculate it all 3 ways. Let's look at this one. A circle with a diameter of 3.3 feet. So D equals 3.3. That's all the way across, okay? So the whole shazam here is 3.3 feet. If I asked you to find the radius, you could find the radius by taking half of 3.3, or in other words, dividing by 2. The radius is 1.65. However, When I am calculating circumference, I need the diameter because circumference says take pi times diameter. So I would take pi times 3.3. If I tell you to leave pi as pi, then simply leave your answer this way, but please write the diameter number in front, okay? So just write it as 3.3 pi, and then what are we in? We're in feet, so we better make sure we put our label there this time. If I tell you to use 22/7, usually they want you to use this one only when you have a number that's divisible by 7, so you get a nice approximation. I'm going to say it really doesn't make sense to use 22/7 here. You get this ugly, ishy decimal number, so we're just going to bypass that one. Really, let's put a note over here on the side. Only use 22/7 if your diameter is a, and I notice I just said D, if your D is a multiple of 7, perhaps. That's typically when you're going to see it get used, all right? Circumference using 3.14 for pi. So circumference would be approximately 3.14 times the diameter, which is 3 3/10. Oh my goodness, right now I am saying thank you, whoever invented the calculator. I can tell you this is about 3. This is a little more than 3. 3 times 3 is 9. My number, my answer should be more than 9, but not by a lot. Maybe close to 10 or something like that. So go ahead and crank this one out on your calculator. And notice you get 3 decimal places here. We get 10 and 362 thousandths feet. Okay. Usually directions will probably tell you to round it off, maybe to the 10th place, maybe to the 100th place, depending. So for now, I'm just going to leave it this way. Okay. It's a little more than 10 feet. All right, let's tackle some of these other examples. Here's one. You get a sprinkler, and it sprays in a circle like this. Choo, 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 choo. I don't think we're ever going to use sprinklers this year because there's too much snow on the ground. Anyway, it says the radius is 14 feet, okay? Find the circumference of the region watered by the sprinkler, and please this time use 22/7 for pi. Why are they saying use this one? Because my radius is 14. That is a multiple of 7. So first, use the formula. Let's write the formula down. Pi times diameter. Now, to find the circumference, I'm changing to approximately. Pi is 22/7. Diameter, whoa, hold on. Here, my radius is 14. My diameter is 28. Let's write 28 here. All right. You go ahead if you want, use your calculator, but I know that 7 fits into 28 exactly 4 times, and 22 times 4 is 88. Cool. Isn't this just like the one we just did on the front? I think so. 88 feet is approximately the distance of that outer edge. Let's look at another one. Here's another circle. Radius is 21. Okie dokie. This is a circular wading pool at the park. Find the circumference of this pool. That's the distance around. My formula says take pi times diameter. This time they are asking us to please use the fraction 22/7 as our approximation of pi. Diameter, hold your horses, that's the radius. My diameter is twice as big. Okie dokie. Go ahead and crank this one out. 22/7 times 42, which is the same as 42 over 1. I know 7 can fit into 42 exactly 6 times. So 22 times 6 gives you 132 feet for your approximate circumference. All right, this one is a little more challenging. So let's take a look at this one. And I know this is super tiny, so I'll talk about this in a second. Here is a circular concrete patio, and we already know the circumference. The circumference is about 1,400 feet, okay? So here they show you in the picture about 1,400 feet. So when I'm thinking circumference is pi times diameter, this time I already have the answer. Uh-oh. A gardener walks directly across the patio along a radius. Okay, so here's the radius. But we don't know how long this is yet. That's actually a question mark in there as far as what's the radius. And it's telling us that he's walking at this certain speed, a rate of 1.5 feet per second, and how long is it going to take him to get from that edge to the center where there's a plant. So we have to work backwards here a little bit, okay? I know the circumference. We know what pi is. Typically, I'm just going to, if they don't tell you, use 3.14.
If there is a James Kistler in the building,
then this is diameter, which we don't know. We're going to find diameter first, and then we can find the radius, and then we can go from there. So first things first. Diameter times this number equals 1,400. So let's figure out diameter first. Grab your calculator and divide 1,400 by 3.14. All right, when we do that, you get, and let me grab my calculator just to be sure. So I'm going to get that my diameter is approximately, and I bet we're going to have to round this sucker, 1,400 divided by 3.14. We get something like 440, and then I get 5.8598726. So if I rounded to a whole number, I get about 446 feet. All right, that would be the diameter the whole way across. First, let's find what the radius is equal to. Divide diameter by 2. Now, we're not quite done yet, okay? So over here, I'm going to draw another circle since I goobed all over this thing. So I know that from the edge to the center, this is 223 feet. There's some sort of planter here, okay, in a pot. Oh, pretty flowers, la, 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 in the center of this thing. We are going to be walking, or it should say a gardener is walking from here to here at about 1.5 feet per second. How long is it going to take him to travel these 223 feet? So take 223 now and divide it by 1.5 feet per second. And this will tell you how many seconds it's going to take him to travel. So now take 223 divided by 1.5. And we get approximately, looks like about 148.6 repeating, or 100. If I round that, that's about 149 seconds, which is about, let's see, 60 seconds in a minute. 60 and 60 is 120. It's going to take him about 2.5 minutes. Seriously? This is a huge honking patio. Okay? So you could just leave this as 149 seconds. Or if you wanted to say it's about 2 minutes and 29 seconds, either of those answers are pretty good. Cool. All right, let's look at the next one. We got a couple left here. The second hand on the clock. Now mine is red here, so you can see this. All right. And it says that it is 7 inches long. Label this 7. That means the radius is 7. If you have radius, you can tell me diameter right away. That's 14. What is the distance that this second hand travels in an hour? Okay. So first, we're going to find how long or how far it travels in one revolution or one circumference here. So let's first of all find circumference, which is pi times diameter. You go ahead and calculate using 3.14. Or should we use, you know what, since this is a multiple of 7, should we use 22 sevenths? Let's leave it as 3.14 for this one. Diameter is 14. All right, when we do that, you get a value that is pretty darn tootin' close to about 40 something. Let's see, 14 times 3.14. 43.96. So if I was going to round that, because I get 43.96, that's pretty close to 44. Okay, so let's just say once around the circle, one circumference is about 44 inches. Now, that once around the circle is 1 minute. They want to know in 1 hour. Well, that means we're going to go around that thing 60 times. So you're going to have to take 60 times that 44 inches and calculate that out. Grab that handy dandy calculator and you get 2,640 inches. Do you have any idea how long that is? 2,640? I can't even fathom that. So go ahead, let's convert this into feet. There are 12 inches in a foot, so take 2,640 and divide it by 12. 2,640 divided by 12. And I get about 220 feet. All right. That I can kind of wrap my eyeballs around a little bit. If you think in terms of a football field, that's about 73, little more than 73 yards. So that's almost 3/4 of the football field. Holy cow. All right, last one. Cool. Ferris wheel. This is what people ride who can't handle the big rides and aren't afraid of heights. Okay. It has a diameter of 56 feet. So from here out to here is 56 feet. If you're sitting in one of these cars and you start going round and round and round and round, they want to know how far do you really travel around this circle when you take 15 revolutions on that Ferris wheel. Well, first we better find one revolution, which is the circumference. Let's use 3.14 this time times the 56-foot diameter. Okay, 3.14 times 56. I get about 175.84, 84 hundredths of a foot. So almost 176 feet. Okay, if we rounded that, why don't we? We'll say that's approximately 176 feet. Now, that's just one spin. You will get 15 revolutions. So now 15 revolutions means take 15 times that 176 feet and go to town there, and you get 2,640 feet, which is about almost exactly half a mile. Wow, that hardly seems possible. Cool, cool, cool. All right. Keep your calculator handy. Pay attention to what they are asking you to do for circumference, okay? This is using either 3.14 or 22 sevenths for pi, okay? And the circumference means this is the perimeter around the circle. Check Schoology for your exact assignment. And as always, good luck. May the force be with you.